Instead, we are going to start looking at, we are going to look at this tutorial sheet from the University of Zambia. There's tutorial sheet 7. There are some questions on trigonometry. So we are going to start from question 1, then we'll see where we'll end until to the last question. So that is the tutorial sheet for those of you. Okay, let me. Right. I forgot to share my screen. Okay. So for those of you that do not have the tutorial sheet, here's the tutorial sheet. So that's what we'll be doing. We're going to start from question 1, which reads, write each of the following as trigonometric ratios of positive acute angles. So you have acute angles, angles less than 90 degrees there. So you can look at the first one, we have sine 90. Sorry. I mean, we have Okay. Right, so let's look at the first one here. So the last time, if you remember, we looked at reference angles. So you use that concept to evaluate this. So for this one, we know you have this measure of rotation. So you are 194. So negative 194 degrees starts from here. That is minus 180. Minus 180. Then you get plus a 14 degrees there. That's when you get 94. So 194 lies somewhere in the second quadrant. But what happens to the sine function in the second quadrant? It is positive. So this value should be positive. So you have that sine minus 194 degrees is simply equal to the sine of 194 minus 180. So that this will give you sine, what you get when you subtract 14 degrees. This is a positive value. And guys, this is simple. You looked at this, then even this one, 481. So you look at there. So this one is more than 360. So you are going to start from here up to 360. Then 360, you find that it's going to go 360 plus 90. So just check. 360 plus 90, you get 0. There you get a 4. And there you get a 5. That's 15, 4. So you get 450. So it is in the second quadrant as well. But what happens to the cosine function in the second quadrant? It is negative. So you have that cos So we have cos 481 degrees be the same as you have cos 481 degrees, say minus 360. You are going to get what there? So you are going to get cos 121 degrees there, but this is off there. So when you subtract this one by 80, subtract this from 180, you get cos 100 minus 121 degrees there. And that will give you, so you have 7 minus 2, you get 5, to give you cos 59 degrees. But what is happening to the cosine function in the second quadrant? You have that it is negative, so this should be a negative here. So you do the same with the rest of the questions. So let's move on to question 2. So write down the possible values of the following, leaving your answer in terms of sides where possible. So you have the first one. You have the first one as cos 7 pi over 6. That is your first one. Right, so guys, here you can deal with this in radian measure or in degree measure, whichever, it doesn't matter. So here, if you want to deal with this in radian measure, you can say, okay, 7 pi over 6 will give you, this will be pi plus, remainder 1 there, pi by 6. And then you're going to replace this by this by this. So this one will become cos. So 7 pi over 6 now will become cos pi plus pi by 6. And then this is a familiar identity where you have that this is equal to cos pi by 6 minus sin pi by 6. But this is a long procedure, guys. This is a long procedure, guys. So, but what you can do here, you can convert this to degree measure and work things out easily. So you have, if you convert this to degree measure, you have cos 7 pi over 6. But 7 pi over 6 is equal to 7 by 180 over 6. So which is equal to 7 by 30, which will give you now 30. What are we getting there? 210. So this one will be cos 7 pi over 6 is equal to cos 210 degrees. Then this one, you use what we are from doing here. So let's do this. So you have that. So we have, this is 180. So you see that this angle here lies in the third quadrant here. So to find this angle here, you simply say, okay, this is the reference angle there. This is 210 minus 180, which you get cos. What is 210 minus 180? So there you have a 0. Then 11 minus this one, you get a 30. So you're going to have 30 degrees there. But what is the sign? I mean, the sign of this one here? The sign of cosine in the third quadrant, all students take. So this one is negative, so this one should be negative. This is equal to negative. So you have 30, what is cos 30 degrees? So cos 30 degrees, you get the root of 3/2. And there you have your answer. So you can confirm here and try to see what you're going to get. So you should be able to get a negative, the root of 3/2 there. Okay, let's move on. So how about, so you have the second one here of sine 9 pi by 4. Okay, so how do we go about that one? So in the same way, we can just convert this one to degree measure. So you have 9 by 180 there, and divided by 4. What do we get here? So you have 2 there, you have 2 there, you have 90. So you have 45 there. And what do you get when you multiply 45 by 9? So you have that sine 9 pi by 4 simply equal to sine 405 degrees. But again, you see this one, you use a reference angle to calculate this one. So you're going to have, this would be equal to, so what is happening here? Let's draw this one here. So you have that this is at 360 degrees. So 360 degrees plus 90, you are getting a 450. So this angle here should lie somewhere here. So you know, okay, let's subtract this one, 405 in the second quadrant there, minus 360 degrees to get sine. So we have 405 minus 360, you're going to get 45 degrees there. This angle is in the second quadrant there, in the first quadrant, and this one value should be positive. So this one is equal to the sine of 45 degrees is simply the root of 2/2. So there you go. So you can do the same with the rest of the questions. For this one here, you can say, okay, this one is sine 9 pi by 4, which is equal to sine this one there, you are going to get 2 pi plus remainder 1 pi by 4. So using this side, this is familiar. So you can, you see that this is sine 2 pi cos pi by 4 plus sine pi by 4 cos 2 pi. So here you're going to get, what is sine 2 pi? Sine 2 pi, that is 360, you get a 0. So even this one here, you have 0 being equal to sine pi by 4, which is 45. Sine 45 degrees, you get the root of 2 over 2 pi cos pi. Cos 2 pi, you should be able to get a 1. So I mean, this here, it's a plus. So this is a 0. This is equal to 0 plus, you have the root of 2 over 2 by 1 there. This will still give you the root of 2 over 2. So that's what you have there. So you can go either ways. It still works. Right. So you're going to do the same with the remaining questions, unless there's maybe a challenging question on question number 2, which we can look at together. So we go to question 3. So question 3 has some identities, and we are asked to prove some identities.
Sir,
So
can you show the same tutorial sheet? Because we are using the same device, so we can access it.
The what? Okay, let's move on to question 3. So that is your question 3. We have it there. So question 3 is asking us to prove the following identities. And then the first one is cos squared theta plus 3 sine squared theta is equal to 3 minus 2 cos squared theta. So let's look at that one. So you have equal to look at that one. So this cos squared theta here. So cos squared theta plus 3 sine squared theta. We have to show that this is equal to 3 minus 2 cos squared theta. Okay, so I always go for the side that looks a bit complicated. So you see, let's go with the left-hand side here. So the left-hand side is equal to cos squared theta plus 3 sine squared theta. Right. So you have a cos squared theta and a sine squared theta, but on the right-hand side, you have a cos squared theta. So the keen interest is in the cos function. So here you have to create a cosine function. How do you do that? You know that. So this one, maintain it. This is cos squared theta plus. So you have 3, but you know sine squared theta is 1 minus cos squared theta. Right. Move the camera. All right. So that's what we have there. So you're going to have that. This is cos squared theta plus this is 3 minus 3 cos squared theta. Then this is equal to 3 plus cos squared theta minus 3 cos squared theta, which is equal to this 3. This is a negative minus 2 cos squared theta. And you've shown there, which is equal to the right-hand side. So the next identity is we have oh, sorry. So the next identity we have cosec theta minus sine squared theta, or just sine theta there. This should give you cos theta cot theta. Okay, here let us consider the left-hand side as well here. So you're going to have, so the left-hand side is equal to, you have, this is cosec theta, which is 1 over sine theta minus sine theta. And this one is equal to, common denominator here, you are going to get 1 minus sine squared theta over sine theta. But you know this, your function, this one minus sine squared theta is simply equal to cos squared theta, then over sine theta. And that will give you something like this, cos theta by cos theta, then over sine theta. So this one here, we are going to get, this is cot. So this can be written as cos theta over sine theta times cos theta. Then you see that this is equal to cos theta cot theta, which is equal to the right-hand side. So you've shown. Let's look at the third one. So we have our third one here. Say this one is cot squared theta plus cos squared theta must give you cosec theta minus sine theta, that multiplied by cosec theta plus sine theta. Right here. So let us consider the right side here. So the right hand side is equal to, so you're going to have this one is 1 over sine theta minus sine theta, then multiplied by this is 1 over sine theta plus sine theta. Right. So you're going to say, okay, so this one here is equal to, when you find the common denominator here, you say this is 1 minus sine squared theta over sine theta, and the whole lot of this multiplied by 1 plus sine squared theta over sine theta. Okay. Right. So you see, then you carry out your multiplication here. So you say this one times that one, you say that is 1 plus sine squared theta minus sine squared theta. Then this minus sine to the 4 theta over this times this one, you have sine squared theta. Wait. Is this going the way it's supposed to go? Right. So you see this is equal to, so this one will go, you have 1 minus sine to the 4 theta over sine squared theta. So this one here is equal to the difference of two squares, you say 1 minus sine squared theta. This is a difference of two squares, then times 1 plus sine squared theta. Okay, I don't know why we had to go to the over. Oh, we are getting back to it. Okay, let's do this. Okay, so let's change this one here. Let's say this one here, you see that this one here, in fact, we are supposed to do this step here. But this one here is 1 minus, this one is very familiar. You get 1 minus sine squared, cos squared theta there. Then multiplied by 1 plus sine squared theta, then over your, so we would have done this here. I don't know why we had to go this way. Then this is equal to y 1 minus 1, then plus cos squared theta. Then this is multiplied by 1 plus sine squared theta. This over sine squared theta. So this 1 minus 1, 0. You have cos squared theta multiplied by that. So you get this one multiplied by this one, you get cos squared theta plus sine squared theta cos squared theta over sine squared theta. Then this can be written as cos squared theta over sine squared theta plus sine squared theta cos squared theta over sine squared theta. So you see, this one here cancels that one, there goes. And this one here, that is very familiar, that is our cotangent function. So this is equal to cot squared theta plus your cos squared theta. So we've shown. So here, on this step here, before you carry out this multiplication here, just here. So before, when you reach this step here, you can come to, where is that step? This step here. Oh, this is a repetition. So from here, you can come here and then you multiply through there. So you're going to see that you get this. So that's what you have there. So we've proven that one. So let's do our next one. Right. So let us look at this one here. You have this one, cos 2x over cos x minus sine x. This should give you cos x plus sine x. All right. So here we are going to consider the left-hand side. So the left-hand side here is equal to, we have cos 2x. We know the identity for cos 2x. We know the formula. This is cos squared x minus sine squared x. Then